Dear students, in the previous class we had a discussion over the group 16th elements, under that some physical properties and one chemical property. That one is oxidation state. How oxidation state is important, and what are the oxidation state of these elements, and how oxidation state varies in down the group and all that, the common oxidation state and all that. The next part is reactivity under the chemical property. The next thing is reactivity. Under reactivity, I would like to take the first one. It is reaction with or reactivity towards hydrogen. Okay, towards hydrogen. How these elements react with hydrogen? Yes, it easily react with hydrogen. The reason is under oxidation state. Under oxidation part, we had a discussion, discuss the one thing, that is it shows minus oxidation state. Correct? The common oxidation state is -2. Hence, it easily react with oxygen because hydrogen. Hydrogen is electropositive, and these are shows negative oxidation state. Therefore, there is a possibility of formation of a stable compound with the hydrogen. And how it react, in what way they react. Okay, let us discuss all these things under this top part. -2 oxygen, because of the -2 oxidation state of these two hydrogens are required. When hydrogen react with oxygen, or oxygen react with hydrogen, gives water. Sulfur react with hydrogen, produce sulfur dioxide, hydrogen sulfide, selenium hydride, tellurium hydride. Next is last one, polonium hydride. So these are the hydrides of all these elements, or group 16th elements. Then what are the important properties of hydrides? Yes, hydrides are these, or the hydrides are in the form of H2E. Here E represent group 16th elements. When group 16th elements react with hydrogen, forms H2E forms. Okay. Next, what are the important properties of these hydrides? The hydrides of group 16th elements shows very important three properties. One is bond dissociation enthalpy. The word itself says bond dissociation enthalpy. Okay, bond dissociation enthalpy. It is commonly, or in the small form, represented is BDE, bond dissociation enthalpy. Here the bond dissociation is between hydrogen and E. What is the meaning of E? Group 16 elements. How, or what is the capacity, or what is, how much energy is required to break the bond between the hydrogen and group 16th elements? That one is called bond dissociation enthalpy. Bond dissociation enthalpy means energy required to dissociate the bond or break the bond. Here hydrogen and group 16th element, how much energy is required? Different hydrides shows different energy. The order of bond dissociation energy is order of bond dissociation energy of hydrides of group 16th element is H2O. Here it is a stable, more stable compound, stable oxide. Because of that, it require more amount of energy to break down the oxygen and hydrogen bond. Here it is greater than H2S, greater than H2Se, is greater than H2, PE is greater than H2PO. This is the order of bond dissociation energy of hydrides of group 16th elements, and here water shows more, or has more bond dissociation enthalpy. The reason is When we move down the group, oxidation state -2 decreases because of increasing the size. When size is increases, strength of or the attraction power of electrostatic force of attraction between the nucleus of central atom and the hydrogen is decreases. When size increases, electrostatic force of attraction decreases, hence the bond dissociation enthalpy decreases. It is completely dependent upon the atomic size. This is the order. So based on the bond dissociation enthalpy of hydrides of group 16th element shows different property. Yes, there are two important property. These all are hydrides, therefore these has a capacity to reduce the other, and it has capacity to donate a hydrogen. When any compounds which has ability to donate hydrogen, then it shows acidic property. Then what is the order of acidic property of these hydrides? What is the reducing nature of these hydrides? Let us discuss it in this part. The first one is acidic property. Okay, order of acidic nature. Acidic nature, how acidic nature is very bond dissociation enthalpy of water is stronger, hence it does not easily donate a hydrogen. Any atom or any compounds which does not easily donate a hydrogen means it is less acidic according to Arrhenius theory. That's okay. Here not easily donate hydrogen. Next, H2. What it indicates? Water is less acidic than hydrogen sulfide. Next, H2, Sc. H2, H2, strong acid. Strong acid. Okay. Always has tendency to donate a hydrogen. Try to donate a hydrogen. Okay. Next, same. Reducing nature. Sorry. Reducing character or reducing nature. Order is same. Water, hydrogen sulfide, hydrates of selenium, hydrates of tellurium, hydrates of polonium. Here, what is the meaning of reducing nature? Reducing nature is completely depend upon the donation of hydrogen. Any compounds which easily donate hydrogen, it's easily reduce the other. So water does not has capacity or does not has more tendency of donating hydrogen, hence it is less shows reducing nature. But the polonium and the tellurium, these are shows more tendency of donating hydrogen, therefore it reduces the others easily, therefore has more reducing nature. So this is the order. Okay, these three are very important for your competitive exam purpose also. What is the correct, give the correct order of acidic character, give the correct order of reducing nature and all that. Okay, so these are the very important concept for you also. Please remember all these things. Okay, this is about the hydrates. Let us move on to the reaction towards hydrogen. Okay, oxygen B. Okay, under reactivity, I would like to discuss the next thing is reactivity towards oxygen. Okay, how it reacts with the oxygens. When oxygen is react with group 16th elements, or the better to call it as oxygen react with her PAMI. So how it react with the family members? These are oxygen family group 16th elements. So how oxygen react with the family members? Oxygen react with oxygen? No. Oxygen atom combine gives a oxygen molecule. Next, how react with sulfur? When sulfur react with oxygen, it forms, or when sulfurs are burned in air, it gives sulfur dioxide. Yes, oxides are formed. Corresponding oxides are formed. Then what is the properties of oxides and what type of oxides are possible? Because of the positive oxidation state, oxygen does not show positive, negative. In few cases it shows positive only with the fluorine. But in other all cases oxygen shows negative oxidation state. Other elements of group 16th element shows negative, in few cases shows positive. When these become positive, then it forms an oxide, positive. So therefore, how oxides are formed? Suppose E is the group 16th element, any one except oxygen, E, sulfur, suppose it's sulfur forms EO2, suppose it's sulfur, another one is trioxide. Trioxides are formed. In case of dioxide, what is the oxidation state of group 16th element? -2 plus 2 here plus 6. What happened? Oxidation state of group 16th element. It may be sulfur, it may be selenium, or it may be selenium or tellurium. Here also same. The group 16th element shows plus 6 and plus 4 oxidation state in few cases. Because of that reason, they form oxides. What type of oxides? Dioxides and trioxides. Okay, so these are the oxidation state. Plus 4 down the group increases, plus 3 down the group decreases. Because of that, trioxides of group 16th elements are unstable. Move down the group, stability decreases. What is the reason? They plus 3 oxidation state is plus 6 oxidation state is decreases. What is the reason of decreasing the plus 6? It is inert barrier. So instability of trioxides of group 16th element is reason, or reason of instability of trioxides of group 16th element is inert pair effect. Okay, so all are interrelated. Let us observe the few oxides. Okay, sulfur dioxide, sulfur dioxide. Next is selenium dioxide, tellurium dioxide, polonium dioxide. So it is existence of this one is less. Here there is no trioxides of selenium and tellurium and polonium because of instability of plus 6 oxidation state. Sulfur dioxide is exist. Then what is the order of the acidic character of these elements or these compounds, oxides? SO2 is less acidic, sorry, more acidic. In case of oxides, reverse of hydrates. Selenium dioxide, next tellurium dioxide. So this is the acidic character. Okay, order of acidic character. It's again important. I will give the one work for you. That one is, what is the acidic nature of sulfur dioxide and trioxide? Okay, it's for you. Work is, you consider as a homework. Okay, you consider it as a homework. What is the acidic order of sulfur dioxide and trioxide? Which one is more acid? Okay, so this is the order of acidic nature of oxides of group 16 elements. Next, reactivity towards halogen. How it react with halogen? Okay, reactivity towards halogen. X. The group 16th element react with halogen in the form of 6EX4 like that. What is oxidation state again? It is plus 6, again it is plus 4. Now you are able to give the correct order and all that. I think yes, plus 6 halides, or sorry, EX6 form of the halides of group 16th element. Move down the group, decreases, stability decreases, existence is less. Here plus 6 oxidation state, move down the group, increases. Because of that, the compound existence of EX6 4 types of compound is more. Okay, more type of these compounds are exist from group 16. SF6, SF, for example, SF6 and SF4, sulfur, hexafluorosulfide, sulfur and tetrafluorosulfide. So these two are the compounds formed from the halogens, and also oxygen forms in different way. That part we discussed in the oxidation state also. Yes, EF What is the existence form of oxides halide? EF2. Okay. Next, selenium F4, tellurium F4. So these are the halides. Okay. Not important. This part is not much important for your exam point of view. So these are the reactivity towards the oxygen and hydrogen to the halogens. Okay, so these are the important chemical properties of group 16 elements. Next we move on to the unique property or unique nature of the group 16 elements. The first member, you already well known about that. The first member of the P block elements mainly shows unique properties. It has some unique property. These properties we can't observe in the other members of the same groups. The first member of group 16th element is oxygen. The oxygen shows some unique property. That unique property of oxygen is considered as or called as anomalous properties. Okay, anomalous behavior or anomalous property. What are the reason? What are the reason of anomalous behavior? Mainly because of the smaller size and more electronegativity, absence of d orbital. Because of this reason, the first member of the p block elements shows anomalous properties. Then what are the anomalous properties of oxygen? Oxygen is smaller, more electronegative when it is react with the hydrogen. It forms a hydride. The hydrates of oxygen is water, and in case of the hydrates of oxygen, we observe hydrogen bonding. What's the reason? Oxygen shows more, because of oxygen, more electronegativity of oxygen and contains hydrogen. One water molecule, oxygen of one water molecule combined with the hydrogen of another water molecule, they shows hydrogen bonding. So existence of hydrogen bonding is observed. But in other hydrates, there is no possibility of hydrogen bonding. So that is the first anomalous behavior. Okay, it is because of more electronegativity. Okay, water in the bulk nature of water, not only one molecule. Water shows hydrogen bonding, while other hydrides other hydrides does not shows hydrogen bonding. Other does not shows hydrogen bonding. So this is the first anomalous behavior. Second, what is the second? What may be the second? About covalence. What is the covalency of oxygen? The covalency of oxygen stands are up to 4 only. Okay, covalency of oxygen O2 is 4. Okay, covalency is 4. So there is the another anomalous behavior. So these two are the anomalous behavior of oxygen. Again, it is important for your theory exam. Okay, there is a possibility of asking the anomalous properties of oxygen for 2 marks. Okay, anomalous properties of nitrogen, there is a possibility of asking in an exam under 3 marks as well as 2 marks, but this one is only for 2 marks. Okay, next let us move on to the next part, that is the compounds of group 16 elements. Compounds of group 16 elements. Here, compounds of group 16th elements. What are the compounds under group 16th elements? Under group 16th elements, oxygen. The very important compound is oxygen. Here we observe one special thing under group 16th elements. The group 16th elements have all the group 16th elements shows allotropy. Then what is the meaning of allotropy? Allotropy, in case of a group 15th elements, nitrogen does not show allotropy. That is anomalous behavior also. Nitrogen does not show allotropy. But other members of group 15th element shows allotropy. We don't discuss that part because it is that part was deducted. Okay, the phosphorus, allotropies of phosphorus, white, red, black. So these three allotropies are observed under phosphorus: white phosphorus, red phosphorus, black phosphorus. And in case of group 16th elements, all members shows allotropy. Yes, oxygen also shows allotropy. Allotropy, the meaning of allotropy is element, same element which has, or same compound which has a different physical properties, same chemical property. It exhibits same chemical property. The allotropy of oxygen is ozone. Oxygen is represented O2, ozone O3. So there are two compounds from oxygen. Both have same chemical property, but they shows different physical property. That's why they become, or they are called as allotropies. Okay, allotropies. Sulfur shows allotropy, selenium, tellurium also shows allotropies. Under the group 16th elements, because of showing allotropies, we discuss more type of compounds. The first compound is oxygen. Okay, let us discuss about oxygen. Oxygen is most abundant element in the earth crust. Yes, it is around 49%, sorry 46%, and in atmosphere 21, around 21% in the form of gas, in the earth crust in the form of oxides. So therefore it is the most abundant element, and it is about occurrence. So it is exist in the form of oxides mainly in the earth crust. Then what are the preparation method of oxygen? How to prepare oxygen? There are several methods are there to prepare oxygen, but in the laboratory preparation, the very important preparation method is from KClO3. From KClO3. Okay, let's discuss about the preparation. Preparation of oxygen. First one is from KClO3. What is the name of KClO3? K potassium ClO3 chloride. Potassium chloride. Okay. How to prepare oxygen from potassium chloride? When KClO3 is heated in the presence of manganese dioxide. Here it is catalyst. Okay, please remember it is catalyst. Please remember it is catalyst. It's not react with the reactant. Only this much. It is nothing but a decomposition method. Okay, because it is supplying a heat. Heat is supplied during the decomposition. Thermal decomposition takes place and forms KCl and oxygen liberate. Then how to balance the reaction? It is odd number, it is even number. Because of that I am multiplying the same even number. So 3 into 2, it will become 6. Therefore I am multiplying 2 to balancing this equation. I am multiplying 2 here. Okay, so this is the method of preparation of oxygen. So this is a very important method of preparation of oxygen. It is very important for your exam point of view also. nothing, it is nothing but a thermal decomposition. Thermal decomposition. Thermal decomposition of potassium chloride. Okay, once again I would like to explain the same thing. When potassium chloride is thermal decomposes in the presence of manganese dioxide, use KCl and oxygen. So this is a very important method of preparation of oxygen. So it is a laboratory preparation. Next, second method is from oxides. We already discussed the same thing. The oxygen exists in the form of oxide in the earth crust. Because of that, the preparation method is very easy. When decompose the metal oxides, then it will easily liberates the oxygen. Then what are the main important element that gives oxygen? Important compounds are Ag, lead, okay, silver oxides, lead oxides, they are easily donate oxygen, okay. Hg, mercury, when mercury oxides are subjected to thermal decomposition, Ag oxides, lead oxides, AgO2, PbO3. So these all are, when these are subjected to thermal decomposition, they use oxygen. Oxygen is liberated. So I will leave the work for you, other things is left to you, okay. Please refer the book or through internet, or just by your knowledge, okay, how to balancing the reaction and all that. And give the hint here, HgO, AgO2, PbO3. Okay, so these are the oxides. These are the main oxides. They use oxygen. Okay, they use oxygen already. Then balance the equations. Okay, multiplying the numbers and give the correct amount of the byproduct that produced during the reaction. It is left to you. Okay, how much quantity? Okay, it is left to you. Please work on it, and it is just a practice purpose. Okay, not important for your exam point of view also, because these are the two methods. Next, last method is decomposition of hydrogen peroxide. When from hydrogen peroxide H2O2, when H2O2 is decomposes, it gives water and oxygen. Then how to balance? 2, 3, even number is there here, and odd number, therefore I multiply 2, 4, 2 into 2, 4, 2 plus 2, 4. Okay, balance it. So this is the decomposition of hydrogen peroxide. Simply leave it, okay. Then hydrogen peroxide leave or open area. When hydrogen peroxide is placed in open area, then it undergo decomposition, gives water and oxygen. So this is another method of preparation of oxygen. Consider a large quantity of hydrogen peroxide and decompose it into these two compounds. Oxygen is liberated, so it is another method of obtaining the oxygen. Okay, so it is just obtaining oxygen. Large quantity is not possible in this case. The large quantity of oxygen is obtained from the oxides of metals. Okay, what we are discussing in the last part. So that one is the important method. Next, what are the physical properties of oxygen? What are the physical properties of oxygen? Oxygen is the colorless gas. Yes. Physical property. Under the physical properties, physical state, it is a colorless, odorless, tasteless gas. Next, solubility, soluble in water, is soluble in, sorry, soluble in water, and liquefaction, liquefaction take place, liquefaction point is around 90 Kelvin and freezes at 50 Kelvin. Okay. Small amount of very small amount of heat, or sorry, temperature. Okay, so negative minus degree in terms of degree Celsius, it's a negative. Okay, 90 Kelvin liquefaction point and 50 Kelvin is the freezing point. Liquefaction point means gases get converted into liquid. Okay, so at what point? 90 Kelvin. And this shows isotopes. There are three isotopes we observed: 16, 17 and 18. Isotope, existence of isotope is observed in case of oxygen. Allotropy is oxygen and ozone, and isotopes are this one: 16, 17, 18. So these are the three isotopes. So these are the main physical properties of oxygen. What are the chemical properties of oxygen? Okay. Under the chemical property, oxygen react with the metal as well as a non-metal. So it shows very important characteristic. They has ability to react with the metal as well as non-metal. When oxygen chemical properties, when oxygen react with metal, it gives a few type of oxides. When it reacts with a non-metal, it gives a few type of oxides. When it reacts with metal, okay, reactivity towards metal, oxygen react with magnesium, magnesium oxides are formed. Yes, no, sorry, Mg 2 plus 2 minus. Calcium react calcium oxides. Okay, 2 is there, therefore we should multiply 2. Okay, so yes, so these are required heat. I will give the few example only. Okay, when magnesium react with oxygen gives magnesium oxide, calcium react with oxygen or burn in presence of air, it gives calcium oxide. Yeah, that means it react, oxygen is react. Okay, what is the conclusion? Metals react with oxygen readily and forms a corresponding metal oxide. It is the conclusion. Okay, metal oxides are formed, or corresponding metal oxides are formed. Next, it also ability to react with non-metals. Carbon react with oxygen, carbon dioxide form. Nitrogen react with oxygen in presence of condition, temperature. Okay, nitrogen forms nitrogen monoxide, nitrogen dioxide, tetroxide converted to hydroxide, and all that. Different types of oxides are formed depending upon the condition, reactivity condition. They forms a corresponding oxides. What's the conclusion now? Just observe the two reaction and give the conclusion. The conclusion is oxygen has the ability to react with the metal and non-metal and forms a corresponding oxides. Okay, also ability to react with the metalloids also. When metalloids react with oxygen, again forms a corresponding oxides. Example: tellurium, selenium, and in the last part, nitrogen and phosphorus. After the nitrogen and phosphorus, Okay, so what are the elements are there that react with oxygen and forms a oxide? That indicates metalloids also ability to form a oxides. Next, oxides. Okay, there's one small part is there. It is oxides. What are the meaning? What is the meaning of oxides? What we discuss the compound or product. So these are oxides. These oxides are shows different characteristic. What are the different characteristics observed in the oxides? Few oxides are acidic, few are basic, few are amphoteric, and few are neutral in condition, and few are superoxides. There are several types of oxides. Acidic oxides, basic oxide, amphoteric oxide, neutral oxide, superoxides, suboxides. So then what are the meaning of, so what are the different types of acidic and basic oxides and amphoteric oxides? These type of oxides form from the different types of the element from the periodic tables. The few elements react with oxygen forms acidic oxide. Few types of oxides react with elements forms basic oxides, and few type of elements shows or react with oxygen forms neutral oxides. Let us discuss about the acidic, basic, amphoteric, and the neutral oxides. First, I would like to take a neutral oxide. Neutral oxides are nitrogen, nitrous oxide, carbon monoxide, and all that. Nitrogen monoxide, nitrous oxides, laughing gas, carbon monoxide. So these are the neutral oxides. What's the reason of neutral oxides? Because of the smaller oxidation state of the element, they are the neutral oxides. Very important for your competitive exam also. Okay, in a few cases there is a possibility of asking the question on these cases, which one of the following is neutral oxide. Okay, next I would like to take the amphoteric. What's the meaning of amphoteric oxide? It reacts with acid, forms a one type of compound, and or better to call, it has ability to react with acid as well as the base. Okay, that one is aluminum oxide. Amphoteric oxide is aluminum oxide, Al2O3. Aluminum oxide is amphoteric oxide. Next, few are basic and few are acidic. On what basis we classified it is acid, it is a base? It is completely depend upon the formed compound when it react with the acids and the bases. Yeah, which type of compound is formed, which type of compound is formed after the reaction with acids and bases. Based on that we classify the acidic and basic oxides. Let us discuss about the amphoteric nature of oxide first. Okay, how it reacts with the acid, how it is react with the base. Al2O3, aluminum trioxide. The reaction is very important for your exam point of view also. It reacts with acid and consider a hydrogen chloride, HCl. When Al2O3 react with HCl in presence of water, it forms acidic compound or acidic complexes. The acidic complex is hexa-aqua chloride. So to balancing the reaction, I am consider 6 amount of yes, 9 amount of water is required, and so cancel this water. Cl3, here 2 aluminum, and first and minus the aluminum 2. When I multiply 2, Al is balanced, Al. Next water quantity 6 into 2, it is here water is not required. Next 3 into 2, how much Cl? 3 into 2, 6 Cl. Okay, here 6 water, 3 water become 3 water molecule. Okay, 6H plus 3 gives 3H2O. Okay, 3H2O plus 9H2O, 12H2O, 6 into 2, 12H2, balanced. Okay, so this is the balanced reaction. Balanced reaction. And there is a formation of a complexes. It gives a complex. What type of complex? It is slightly acidic complex. When Al2O3 react with acidic complex, it forms acid. Therefore, it is considered as acid. Next, or in another word, the complexes are formed. After the reaction with acid, it shows basic. Sorry, it shows basic character. Here, Al2O3 in the next case react with NaOH and water forms Na3 AlOH. Okay, balancing now the reactions. 2 aluminum, 3 into 2, 6 NaOH into how much quantity of hydrogen? 6 hydrogen, and here is 2, 2 into 3, 6, 6. Okay, now 12. How to make it 12? 6. Yes, now reaction is balanced. Okay, Al2O3 react with sodium hydroxide in presence of water. It gives a complex, a basic complex. Here, the complex is formed after the reaction with the base. It shows acidic. That means it is acidic. Aluminium react with acid as well as a base, therefore it is an amphoteric, or it shows acidic as well as basic character like water. So therefore it is an amphoteric oxide. Okay, aluminium oxide is amphoteric oxide. Next, on what basis we classify the acidic and basic oxides? It is depends upon the formed compound or the product. What type of product formed? In case of sulfur dioxide react with H2O, okay, it forms H2SO4. Sorry, sulfur dioxide. Okay, next, sodium oxide react with water. What is the product formed with sodium oxide? NaOH. 2 NaOH. OO, 2 hydrogen. And consider 2. Example. After that, I would like to explain another 2. Here, the formed compound is acid. Here, formed compound is basic in nature. Any oxides, any metal or non-metal, metallic oxide or non-metallic oxide react with water, or when it is dissolved in water, if it gives acidic compound, then the oxide is acidic. If it gives the basic compound, then the oxide is basic. So on that basis we classify the acidic and basic oxides. I am considering another one example. Magnesium oxide react with oxygen, NgOH twice. What is the nature of this oxide? Basic. That indicates magnesium oxide is basic oxide. Okay. Similarly, in case of phosphoric oxides, carbon dioxide. I would like to take carbon dioxide once again here. And when I made to react with the carbon dioxide and water, it becomes HCO3. Correct. Carbonic acid is formed. To balancing this reaction, we should multiply 2 into 3, 6, 8. So carbon dioxide. This one is acidic. Acidic for compound is formed. That means oxide is acidic. Yes, carbon dioxide is acidic. Acidic rain is formed. So you are well known about that thing. I think you are well known. Acidic rain and all that. Okay. So carbon dioxide is acidic. So this is the way of identification of acidic and basic oxides. Okay, in the next class we will discuss about the allotrophies of oxygen. Okay, thank you for watching.